Hello, students. Very good afternoon, all of you. I hope all of you are doing well. Then your Pongal or Sankranti holidays, it is also over. Maybe you have some exams. Some exams are waiting for you, right? So you have to study well. You have enjoyed. I hope you have enjoyed the Pongal holidays and the Sankranti holidays, right? Then back to JNV again, studies and again with your friends, some enjoyment, right? All sort of things are there in JNV, right? Okay, so we are studying about our chapter hydrocarbons. So hydrocarbons, we have studied alkanes, right? Then alkenes, introduction to alkenes also we have studied. Now we have to study about some more new topics. So before that, I'm launching the technical check. If there are any issues with the internet, audio, video, etc., let me know. We will solve it and we will go forward, right? Okay, I have launched the technical check here. If there are any issues, let me know. We will sort it out. Okay, good. I hope technically everything is fine. Perfect. Okay, good. It's time to start. So let's start it. So today we are going to study about alkenes. Sir, again alkenes? Yeah, again alkenes. There are a lot of things about alkenes. And we are going to study about reactions or chemical properties of alkenes. Sir, is it important? Of course. Next year also, you will write the same type of reaction. If you're studying it now itself, then good for you. Otherwise, next year you have to work hard. Okay, there won't be enough time for you. Next year, lab, then class, exams, etc. So study it now itself. So let us start it. So before that, what we have studied in the last class, it is very important. Recap or revision is very, very important for you. So what we have studied, we have started alkenes. They are also known as olefins. Why? They are oil forming. Then IUPAC nomenclature, suffix E, right? Then isomerism we have studied. We have done some questions also. Then preparation of alkenes. We were discussing about the preparation. We have studied about one preparation, right? From alkynes we have studied. There are two methods. We can use Lindlar's catalyst, then cis alkenes form. If you are using sodium in liquid ammonia, Birch reduction, then you will get trans alkene. So that is the point. We are studying about the preparation of alkenes. Then today we will study about the preparation from alkyl halides. So what is that? So what is happening? So what is the reaction? So which are the steps involved here? Okay, so let us start today's class. Then last day, I gave you two homework questions. So what is the correct answer? Which conformation is more stable? That is a staggered conformation of ethane is more stable than eclipse. So that is a correct answer. Then one more homework question. 2-butene, geometrical isomerism in alkenes we have studied. So what is that? Restricted rotation. That is the correct answer. So that is the answers for your homework question. So let us study preparation of alkenes from alkyl halides. So what is this alkyl halides? We have studied IUPAC nomenclature. We have studied RX, that is alkyl halides. Then aryl halides are also present, right? Then let us start a preparation. So this is known as dehydrohalogenation. From the name itself, we can understand what is going to happen. D means removal. D means removal is so D means removal. So D, that is our removal. So what we are removing here? Hydro, that is hydrogen. Halo, that means halogen. So we are removing hydrogen and halogen. So that is why it is known as dehydrohalogenation, right? Then reaction. We have an alkyl halide. So methods of preparation means what? So we have some functional group. We are adding some reagent. Then that will be getting converted into our alkene. Here, alkyl halide. We are taking alkyl halide. Then we need something, right? So that is alcoholic KOH and delta means heat. We are giving temperature, high temperature. So alkyl halides is getting converted into alkene. So what we are doing? Dehydrohalogenation. Hydro. Here we have hydrogen. Then here we have halogen X. We are removing them. Then carbon, it is tetravalent. It will make 4 bonds. If I remove X and hydrogen, then this carbon, 2 carbon are short of bond, right? Then this carbon and carbon, they are brothers. They will make a bond with each other. So that is happening here, dehydrohalogenation. So what is this halogen? Can be chlorine, bromine, iodine, etc. Then this is also known as beta elimination. Why it is known as beta elimination? That is a question for you. Suppose we have a halogen. X, chlorine, bromine, iodine, etc. This is attached to this carbon. That carbon is known as alpha carbon. Then adjacent to this carbon, there is one more carbon, right? That is known as beta carbon. Okay. Then what is beta hydrogen? This hydrogen attached to this carbon, that is known as beta hydrogen. So why it is known as beta elimination? From beta carbon, one hydrogen is removed. That is why it is known as beta elimination. So alpha, beta, beta position, one hydrogen eliminated, right? So that is why it is known as beta elimination. So mechanism. Mechanism is what are the steps involved in this reaction? The reactant is not directly getting converted into product. In between, there are so many things happening. So we have to study about that. Then it will be easy for you to answer the questions. So mechanism. First, we have to take alkyl halide, right? Then we have to take the reagent. So KOH is present. I can write it as K plus and OH minus. K plus and OH minus. Then in the next step, what is happening? Here we have a hydrogen. Here we have a hydrogen. This OH minus is coming to this hydrogen. And he's saying, let's be friends. Okay. Friends or relationship. So hydrogen and this OH, they are trying to make a new friendship. Then this green, this is green. Okay. So green means some new bond is going to form, right? Then here also green. Then what about this red? Red means danger. So that bond is going to break. So hydrogen and OH, they are good friends. Then after that, carbon is saying, after that, this hydrogen is saying to carbon, I have a good friendship with OH. Then I don't want your friendship. So let us break up, right? So this bond will get a break. Then what about this one? This carbon, carbon. Now one hydrogen is going away from carbon, carbon tetravalent, 4 bond, right? So this carbon is worried. That time, this next carbon, that is his brother. So during that time, hard time, brothers will come to help you. Then carbon, carbon, their bond is getting strong. 1 pi bond, one more bond is formed. Now it is valency that is satisfied. It is forming 4 bond. Then what about this one? This carbon halogen. So carbon halogen, first brother, carbon, carbon brothers. So this carbon has to take care of his brother. Then only the stranger halogen. Then this carbon halogen bond, that is lysis, breaking, right? Then here it is a transition state. It is not directly, the bonds are, it is not directly getting broken. Then some transition state, there is a transition is formed. So we can say it is a transition state. In the next step, what is happening? So we can remove this, water, we can remove the water. What about halogen? This halogen, that is X minus, it is taking all the electron from the bond and it is leaving. It is saying tata bye bye to our carbon. So X minus is formed and water is eliminated, right? So water is eliminated. Then what is formed? There is a double bond formed between carbon and carbon. So that is our alkene. Then our K plus is waiting here. If needed, this K plus and X minus, they can combine together. They can make a new friendship. That is also possible. So this is a mechanism. In the presence of what is this al? That is alcoholic KOH. Okay, KOH, alcoholic KOH, we are heating. This is an elimination reaction. We are eliminating dehydrohalogenation. We are removing that. So that is a mechanism for that transition state. So OH is coming, making friendship. At the same time, this bond between carbon and hydrogen, that is getting weakened. Then carbon-carbon bond, a new bond is getting formed. Then carbon halogen, that is getting weak. So that is formed, not directly. That is known as transition state. So transition state, we will study about this next year also, right? Then example, how to write it simply. So we have CH3, CHCl, CH3, right? So this is our alpha carbon. This is beta carbon. This is also beta carbon. So this is dehydrohalogenation. I had to remove one hydrogen, one halogen. Suppose I am removing one halogen from here, only one halogen. Then one hydrogen from this carbon. Then what will be formed? CH3, CH, double bond, CH2. What is that? That is our propene, right? So propionine or propene, alkene is formed here. Suppose I am removing hydrogen from this carbon. Then what will be formed? Then also propene, right? So we are getting the same product, whether we are removing this hydrogen or this hydrogen, we are getting the same product, that is our propene, right? Then one more example for you. CH3, CH2, CHCl, CH3. in the presence of alcoholic KOH, that is elimination. Dehydrohalogenation, hydrogen and chlorine we have to remove. So what can we do here? So what will be the product obtained here? So you can tell me the correct answer in the chat. I'm waiting for your answers. Okay, fast. I will give you 10 seconds to tell me the name of the product. So which product will be formed here? So what are the possibilities? Okay, I got answers from some students. There are two possibilities. Why there are two possibilities? This is our alpha carbon. This is also beta. This is also beta. From where you will remove one hydrogen. Suppose this is beta 1. I am removing hydrogen from beta 1. Then I will get this product. What is this? 1, 2, 3, 4. So I can write it as but1e. I'm getting but1e. Suppose I'm removing hydrogen from beta 2. So what will be the product obtained? That is 1, 2, 3, 4. The position of double bond that is changed. So I can write it as but2ene. So but2ene. So who is a major product? But1ene or but2ene? So how can we decide that? For that, I have a new rule for you. This is known as CHEM rule. So what is the CHEM rule? So CHEM rule helps us to find the major product in the elimination reaction, beta elimination reaction. CHEM rule is saying that hydrogen atom, which leads to the formation of more stable alkene, is removed. From where we have to remove hydrogen? We can remove hydrogen from any carbon. But after that, some product is formed, that is our alkene, that should be more stable. So let us check it out. Here we have but1ene, but2ene. Which one is more symmetrical? So let us, I am standing here, I'm going to this side. Okay, same CH3. This side also CH3. So I can say this is more symmetrical, but2ene, that is more symmetrical. So which one is the CHEM product here? So but2ene, that is a major product here. Or I can call it as CHEM product. So it is based on CHEM rule. So this is an example. You have to remove halogen. You have to remove hydrogen, alpha carbon, beta carbon. You have to decide from where you have to remove this hydrogen. It is based on CHEM rule. Next year also, you will study about this CHEM rule. If you are studied now itself, it is perfect. It is fine for you. No need to take heavy burden next year. So that is it. CHEM rule. You have to remember more symmetrical alkene is formed. The CHEM rule favors more stable alkene or more symmetrical alkene. So that is a major product or CHEM product, right? Then what are the points regarding this beta elimination? So what are the points? What are the points involved here? So let us check out some points. Here, carbocation. What is carbocation? That is intermediate. There is no carbocation formed here. Then we have studied if carbocation is formed, suppose primary carbocation, then secondary, tertiary. Which one is more stable? That is secondary. Then highest, that is for tertiary. If primary carbocation is formed, then system will say tertiary carbocation is more stable. If there are some probability, then system will try to convert this primary carbocation to tertiary carbocation. So, very important point, if carbocation is formed, we have to check the possibility of rearrangement. If some rearrangement takes place, will it be more stable than our initial product, initial intermediate? Okay, so in this reaction, no carbocation is formed. So no rearrangement, we can directly write the product based on CHEM rule. Then order or rate of reaction. There is a separate chapter next year, chemical kinetics. You will study about the rate of reaction. We know alkyl halides, there is tertiary, primary, secondary. So which one is highest, least reactive? That is primary alkyl halides. Then highest, that is our tertiary alkyl halide. So tertiary, secondary, primary, that is order. So this reaction depends upon the nature of the alkyl halides also. Then, so these are the important points regarding our beta elimination. Here, elimination is taking place. From beta carbon, hydrogen is getting removed. That is a point, right? So, one more. We are studying about methods of preparation. There are a lot of methods to prepare our alkenes. Next method, that is vicinal dihalide. So, what is this vicinal dihalide? So, do you know what is this vicinal dihalide? JNV Palakkad, welcome to the class. Then what is happening here? Vicinal dihalide. So look at here. This is your mother. This is your friend's mother, neighbor. Okay. Then this is you. Then this is your friend. Okay. Then if halogen, you are the halogen. If the halogen is attached to adjacent carbon atom, first halogen to this carbon, then this is your mother. This is you, your friend, then his mother. Then that is known as vicinal dihalide. They are neighbors. Then what is geminal dihalide? Geminal means this is your mother. Then two children, two son, two daughter. So that is known as geminal dihalide. Two dihalide, two halogen. So two halogen is attached to the same carbon. That is known as geminal dihalide. So this is our vicinal dihalide. Okay. So vicinal dihalide, that is clear. Then it is you. You are creating so much problem. You and your friend. Then mothers are saying, okay, JNV, there is a JNV test. So let them go to JNV. So the sink is the JNV. Sink is coming and taking both of you to JNV. The mother is thinking that after going to JNV, you will be very good. I don't know about that. Then what is happening here? We are removing two friends from the house, neighbors. Then what will be formed? Carbon tetravalent. 4 bonds will be formed. Then carbon, double bond carbon. Alkene is formed. Then what is the role of zinc? That is our JNV. That is taking our halogen. So zinc metal is a good halogenating agent. What is dehalogenation? D means removal. So what we are removing? We are removing the halogen. So that is why it is known as dehalogenating agent. Okay, Sanjeev, JNV Palakkad, 2 JNV Palakkad. Okay, 2 JNV Palakkad. Okay, great. So you two friends can give me the answers in the chat box if I ask some questions. So zinc metal, that is our JNV. So alkene is formed. So what is vicinal dihalide? You and your friend, neighbors, right? Then here we are going away from the home. Then two mothers, their bond is getting stronger. Double bond is formed. So carbon, double bond carbon, alkene in the absence of their son. Then what are the other points? Example. Dehalogenation. We have to remove halogen. So here we have a vicinal dihalide. So what we have to do? So remove one bromine, remove one more bromine, then two mothers bond, double bond is formed in between. The bond is getting stronger. So 1,2-dibromoethane, 1,2-dibromoethane in the presence of Satan. It is a dehalogenating agent. Then ethene is formed. So alkene is formed here. Then you can write Satan PR2 that is formed. So vicinal dihalide to alkene. So JNV is coming and taking this halogen, 2 halogen, vicinal dihalide. Then alkene is formed here. So that is another method of preparation. Okay, JNV Palakkad 3. Great. A lot of JNV Palakkad. Great. Just a second. Okay. I hope this is clear to you. This one, vicinal dihalide. Okay, right. So let us move forward. So preparation of alkenes from alcohols. So what is alcohols? You know alcohol, right? Methanol, ethanol, etc. IUPAC nomenclature we have studied. So here what is happening? From name itself, we can identify from alcohols by acidic. So some acid is present. Dehydration. D means removal or elimination. Hydration, that is water. So in this case, we are removing water in the presence of acid. So acidic dehydration. So what we have to take? We have to take alcohol. So OH, that is our functional group. This is attached to this carbon, that is alpha carbon. Then adjacent to that carbon, there is one more carbon, right? That is known as beta carbon. What about this hydrogen? That is known as beta hydrogen. So alpha carbon, beta carbon, there is a beta hydrogen. So we have to remove water. So what we have to do? We have to add concentrated H2SO4, then heat that one. So H2SO4, that is the acid. Acid means it will liberate H+, right? So you have to remove water. Here we have hydrogen. Here we have OH. Then simply remove that. Then make a double bond. C, double bond C. Then H2O. We are removing H2O in the presence of an acid. That is known as acidic dehydration. It is very simple, right? But there is a mechanism behind that one. So what is the mechanism? First, we have an acid. acid, they will liberate H plus. So H plus and HSO4 minus is formed here. Then what is the next step? So we have to take the alcohol. So I'm taking alcohol. Then we have OH group, oxygen. It has lone pair electrons, right? Then we have an H plus present. Then what is happening here? This H plus, using the lone pair, this oxygen is asking this H plus to come close to that one. Then H plus is coming. So initially, this is our alcohol. This is our alcohol. Now what is coming? H plus, that is proton. So we can call this as protonated alcohol. OH, now it is OH2 plus. Why? H plus, it came there. So this is known as protonated alcohol. So why we are doing this protonated alcohol? So we want to remove this OH, right, to form the alkene. Actually, this OH group is a poor leaving group. It is not ready to leave the system. In order to make it a better leaving group, we are doing protonation. So we are adding one H plus, then OH, right? OH2 plus, that is formed, that is known as protonated alcohol. Then what about the next step? Then we can remove H2O. So what is happening? H2O. So here there is a bond between carbon oxygen. This oxygen is taking all the electron from this carbon oxygen bond. Then it is going. So if it is taking electron, negative charge, positive, negative, that is neutral. So I will get H2O, right? Then this carbon is giving electron to oxygen. So some positive charge will be formed on this carbon. So that is carbon. This carbon is getting positive charge. If there is positive charge on carbon, that is known as carbocation. We know the stability of carbocation. Already we have studied. Then what are the things remaining? There is a carbon with positive charge. Then this carbon has a hydrogen present here. So what we have to do with this hydrogen? So let us check it out. This H2SO4, it has given one H plus and HSO4 minus. H plus, it went with our OH. Now HSO4 minus, that is alone. He need a partner. So HSO4 minus is coming and he is asking this hydrogen to come with him. Okay, so HSO4 minus, it will take one H plus. Then this carbon hydrogen bond. So all the electron, carbon hydrogen bond, hydrogen is ready to leave all the electron, all the money to this carbon. And it is going with our HSO4 minus. So what will be formed? H2SO4 will be formed here. Then what about this one? What about this one? A double bond is formed here. So double bond means alkene is formed here. So alkene plus H2SO4. So in the examination, what you have to do? You have hydrogen, you have OH, remove that. So you will get the product, you will get our alkene. So what about the mechanism? This is a mechanism, alcohol. It is getting converted into protonated alcohol. Then after that, carbocation is formed. If carbocation is formed, right? If primary carbocation is formed, in that system, there is some possibility for rearrangement. Then system will do the rearrangement. So what is rearrangement? That is primary to secondary. Secondary is more stable, or you can go to tertiary. It depends upon the condition. If it is possible, then system will do it. Why? It will get more stability. Tertiary carbocation is more stable in nature. So this is a mechanism for that one mechanism. I hope the mechanism is clear to you. Acidic dehydration. So no need to stress on the mechanism. Simply you can remove H and OH, then add the double bond, you will get the product, right? I hope this is clear to you, for you two friends also. Acidic, that is H2SO4, dehydration, remove the water. Okay, so that is happening here, right? Then example for you, you have CH3, CH2, OH. Leave the mechanism. What you have to do? There is OH, there is hydrogen, alpha carbon, there is OH, beta carbon, there is a hydrogen. Remove hydrogen, remove OH, then you will get the product, that is our alkene. So I'm removing hydrogen from this carbon, then OH from this carbon alpha, this is our beta. What is formed? An alkene is forming between, a double bond will be formed here. So one more example for you, butanol. So what will happen here? Butanol. So which product will be formed? More stable product will be the major one, right? So we have alpha carbon, we have beta carbon here, right? Then the product obtained. So take OH, remove H, then you will get alkene. So alkene is formed here. So we have already discussed. Okay, maybe JNV Palakkad has not joined that time. So but2ene, that is more symmetrical product. That is this side also same. This side also same. So it is a symmetrical product. So that is why it is a major product. But2ene is formed here, not but1e. Okay, why? It is more symmetrical, it is more stable. That is why but2ene is a major product. Then, so that is an example for you. Example for you. Okay, JNV Palakkad students. Okay, we'll explain that once more. Okay, so we have alcohol, right? Acidic dehydration. So take the acid, H2SO4. It will give H plus. It will release H plus. And what is remaining? HSO4 minus. Then H plus is coming to our alcohol. There is lone pair of electron. This OH is taking the H plus. H plus, that is proton, right? So to this alcohol, one proton is coming. So what is formed? OH2 plus, OH2 plus. So proton and alcohol, we can call it as protonated alcohol, right? Then actually this OH group is not ready to leave the system. We have to remove the OH, then only alkene will be formed. So that is why we are doing protonation. What about this group? This group, it is ready to leave the system, OH2 plus. Then what will happen? This carbon oxygen bond, we have to break that. This oxygen will take all the electron from this bond, that is negative. If oxygen takes electron, negative and positive, neutral. So I will get water. So water is removed from here. Then this carbon is losing the electron. Oxygen is taking the electron, right? All the electron from the bond. So carbon will get positive charge. So carbon with positive charge, that is known as carbocation, right? So carbocation is formed. Then this carbon, there is hydrogen. Then our HSO4 minus, it is waiting. Okay, it is very sad. Why? It has lost its lower H plus. So HSO4 minus, it is waiting here. That time, he saw one H hydrogen here. So this hydrogen is giving all the electron to the carbon. That means H plus will be formed. This H plus will come to HSO4 minus. Then what will be formed? H2SO4. Then what about this one? Carbon. Electrons are present here, minus and plus. A double bond will be formed between carbon and carbon. So alkene is formed here. Then H2SO4. Then why it is known as acidic dehydration? In the presence of acid. Dehydration, we are removing a water. Is that clear to you, JNV Palakkad students? Protonation, protonated alcohol. Then remove the water. We are removing the water. Then a carbocation is formed. Then HSO4 minus is coming and taking one hydrogen. Then a double bond will be formed between carbon and carbon. So that is a mechanism. For the exam, what do you have to do? There is hydrogen, there is OH. Remove them. Right? Water, then carbon, double bond is formed. Is that clear to you, JNV Palakkad students? Protonation. So to make it a better leaving group. Then remove the water. Carbocation is formed. So carbocation, if carbocation is formed, you have to check the rearrangement. Suppose primary carbocation is formed, system will try to make it as secondary. So why secondary? It is more stable. Okay, good. Revise it once more. After the class, you can revise it. Go through the mechanism once more. It will be clear to you, right? Then examples, we have done the examples. Then but2 is the stable one. Okay, this is a very important question. So write the question in your notebook. Then we have to solve that. So what is happening here? Here I have an alcohol in the presence of an acid. So acidic dehydration. Okay, JNV Palakkad 2 and 3. Okay, good. So concentrate the H2SO4. So simply you can remove OH and hydrogen. But it is better to write the mechanism. Otherwise, there is a chance of getting a wrong answer, right? So try it. So what will be the product obtained? So what will be the product obtained here? So you have to try it. So let us do it together. That will be better. Okay. So initially we have an acid, right? So it is leaving H plus and HSO4 minus is formed. Then what is the next step? This H plus will come to our alcohol. So if it comes to our alcohol, this is our OH group, oxygen lone pair of electrons. Then what will be formed? Protonated alcohol will be formed. So H plus is coming, initially alcohol, proton. So protonated alcohol. So protonated alcohol is formed. So up to that, it is clear. So can you tell me what is the next step? There is OH2, there is carbon oxygen bond. OH2 plus is there. So what is the next step, JNB Palakkad students? So what will happen next? First one is protonation. So I got protonated alcohol. So what is next? So what is next? This carbon oxygen bond. So oxygen will take all the electron and leave. So what is formed? H2O is formed. So we have removed H2O. So if I remove H2O, what about this carbon? This oxygen is taking all the electron. So there will be positive charge on that carbon. Positive charge on carbon means carbocation is formed, right? So carbocation is formed. Now you have to tell me, carbocation is formed. So which carbocation is formed? Primary, secondary, or tertiary? Primary, secondary, or tertiary? How to check that? Check the carbon. This carbon is attached to one carbon atom. So it is a primary carbon. So which carbocation is formed here? So can you tell me the answer? Which carbocation is formed here? Primary, secondary, or tertiary? So of course, that carbon is primary. So primary carbocation is formed. What about the stability? Primary, secondary, tertiary. So primary has least stability. If there is some possibility, then our system will try to rearrange to form secondary or tertiary carbocation. It will try. Okay. So this is our whole system. This is your family. Then this is your uncle with positive charge. If I do some rearrangement, whole family will be very stable. Then this is your father. This is your father. Okay. Then your father is saying, my son is here, or daughter is here. He is not doing anything, simply eating. So I will send my son to your house. Then our whole system will be more stable. So your father is sending son to uncle's home. So what about your father? He will be very peaceful state of mind, right? So this hydrogen is going to his uncle's house. How? It is taking all the money from father and going far away, going to uncle. Then what will happen? So let me write this carbon with positive charges 1. Next carbon has 2. Okay. So second carbon has 1 hydrogen, his son. He's sending son to next one. For what? To attain stability for the whole family. Right? This is primary carbocation. If I ask this hydrogen to leave my home, then what will be formed? This is known as 1,2 hydride shift. This hydrogen is taking all the money and going to uncle's home. So this is 1,2 hydride shift. If 1,2 hydride shift is formed, what will be happening? So this is CH2 plus. This H minus is coming, is getting attached. So CH3 is formed here. This is your father with positive mindset, peace. Okay, C plus. Now can you tell me which carbocation is formed here? This carbon is attached to 1, 2, 3. So after 1,2 hydride shift, which carbocation is formed here? A tertiary carbocation is formed here. So rearrangement happen. In between, rearrangement is happening. So why? To attain more stability. Like human beings, these organic compounds, they also want to attain stability. So hydrogen is going to uncle's home. Your father is getting positive mindset, positive charge, peaceful state. Then what will happen next step? Next step, our HSO4 minus, it is waiting. It is waiting. Why? It has loss is lower. H plus. So he need one H plus from this organic compound, tertiary carbocation. So it will easily take the hydrogen H plus. Then this carbon hydrogen bond, we have to break that. All the electron will go to carbon. Hydrogen is leaving as H plus. So H2SO4 is formed. So what about the double bond? So double bond will be formed between these two carbon atoms. Okay. So this is the mechanism. Rearrangement. Primary carbocation to tertiary carbocation. Now the product is different. So if the reaction, if some carbocation is present, try to write the mechanism. Okay. Why? If carbocation is formed, then there will be rearrangement. There is possibility for rearrangement. So it is better to write the mechanism. Okay. After being an expert, you can write it directly. So this is primary carbocation to tertiary carbocation. So what is happening? Hydrogen, it is going. H minus is leaving his house, but it is taking all the money from the father. So this is known as 1,2 hydride shift. Right? So 2,3-dimethyl butadiene, that is a product obtained. So I hope this is clear. Maybe this is somewhat tough for you. Why? You are hearing it for the first time or second time or third time. So next year, you will do this for almost all the questions. So wherever carbocation is formed, you have to check whether rearrangement is possible or not. Okay, so this is a very important question for a very important question. So protonation, then I'm removing water, then rearrangement of the carbocation primary to tertiary. Then HSO4 minus is coming and taking the H plus. So I hope this is clear to you. Okay, so that's all about preparation, methods of preparation of our alkenes. Okay, now we have to study the properties of alkenes. So very simple. There are very simple properties for our alkenes. What is that? So lower members C2 to C4, it is in gaseous state. Why? Molecular mass is very low. Van der Waals force of attraction, that is very low. So they are far away from each other. So they exist in gaseous state. Then middle members C5 to C18, liquid. Then higher members C19 onwards, they are solid. Why? Molecular mass is high. Then van der Waals force of attraction. Then they will come closer. Then they will exist in solid state. Then one more point. Generally, alkenes are colorless. Then they are generally odorless. There is no smell except ethene. Ethene has some smell. Okay. Then they are insoluble in water. We have studied the properties in alkanes. Same. Okay. Almost same. There are some differences also. Then this is insoluble in water. Then it is soluble in what? It is soluble in non-polar solvents. Example, benzene, ether, etc. They are non-polar solvents, CCl4, etc. So these are the physical properties of alkenes. So no one will ask about these things. Okay, it is not that much important, but just the basic information, introduction to alkenes like that. Okay, then this boiling point. What is the relation between boiling point and increase in molecular mass? Again, force of attraction. Molecular mass is increasing, force of attraction is increasing, boiling point should be increased, right? Then structural isomers. So we have studied this in the case of alkane. Same points I'm repeating. When what about the boiling point? I have a straight chain, I have a branch chain. So which one will have higher boiling point? So what is the reason for that? This point we will repeat. Alkanes, alkenes, alkynes. Next year, there are so many chapters. There also we will repeat branched or straight chain. Which one has higher boiling point? Branch means like a sphere, surface area that is decreasing, force of attraction decreasing, then boiling point is decreasing. Straight chain isomer, they have a higher boiling point. So that is a point here that we have already discussed. Okay, so it has higher boiling point. Then what's the relation between boiling point and surface area? Relation between surface area and van der Waals force. So branch means like a sphere. Surface area is low. Van der Waals force of attraction low. Boiling point is low. That is a point. Physical properties of alkenes. It's very easy as we have studied this in alkenes, right? Then this is very important. Our chemical properties of alkenes. So what is this chemical properties? So chemical properties means what is methods of preparation? We have some functional group. We are adding something to that one. We are getting alkene. Chemical properties or chemical reactions of alkenes means we are taking alkene. We are adding some reagent. So this will be getting converted into some other functional. So that is a difference. So methods of preparation from this side to this side. Just opposite of that one, that is the chemical properties. First one is addition of halogen. Halogen, fluorine, bromine, iodine, etc. So we have to add halogen. We have studied about addition reaction. So first I had to take alkene. Then to that I had to add halogen X2, right? Then what will be formed? X2 in the presence of CCl for carbon tetrachloride. Then halogen, there are two halogen, right? They will be added to this carbon, to adjacent carbon. If halogen are present in the adjacent carbon atom, that is known as vicinal dihalide, you and your friend, neighbors, right? If you, this is your mother, then two daughter, two brothers, or two sons, then that is known as germinal dihalide. So this is vicinal dihalide. So what about this one? X is added to this side. This X is added to this side. Is it syn addition or anti-addition? Opposite side, right? So I can call it as anti-addition. So what you have to do? You have halogen, then break the double bond, that pi bond, then add halogen to opposite side. Anti-addition is happening here. So that is addition of halogen. Actually, there is a mechanism behind this one also, but it will be more confusing for you. For the time being, I'm not adding that mechanism. You will study it later also. You have to study this halogenation reactions. Okay, so you can study it later. Then what are the important points of halogenation? Addition of halogen. It is anti-addition. What is that? Halogen are added to the opposite side, right? Then there is no rearrangement. So in the mechanism, no normal carbocation is not formed. If carbocation is formed, then rearrangement, there is possibility of rearrangement. So no carbocation. You can study like that. Actually, mechanism is somewhat different. We will study it later. So there is no rearrangement here. Actually, in this, a non-classical cation is formed. Okay. In told, you will study about this classical and non-classical. Then iodine, important point. Iodine does not show addition reaction under normal condition. Why? I have fluorine, chlorine, bromine, iodine. Down the group, reactivity is decreasing. So iodine, it is not showing this addition reaction under normal condition. That is another point. Then what about this bromine? Our bromine, Br2, bromine water, Br2 in CCl4, that is reddish orange color. Okay, then I'm adding alkene. Then what will happen here? Then alkene, the double bond will be broken, right? This bromine will be added to this alkene. Then what about the color? Then reddish orange will be disappearing. Then, so what is the point here? Reaction with bromine water is used as a test for unsaturation. I am adding an organic compound. If the color is changing, I can say there is an unsaturation. There is a pi bond present here. Then pi bond present, we have to break the pi bond. This bromine will add to that carbon. So that is why the color is changing. Br2 in CCl4, reddish orange. If I'm adding an organic compound having a pi bond, so bromine will be added to that one. Then color will be disappearing. So as a test for unsaturation, whether double bond is or unsaturation is present or not, we can use this test. This is a test for unsaturation, Br2 CCl4, then add alkene. If color disappears, then there is a pi bond present. So these are the important points regarding our halogens or addition of halogens, right? So I hope this is clear to you. Very, very simple points. Then mechanism, we are not studying it now. We will study it later. Okay. Then addition of hydrogen halide. So addition of hydrogen halide, what is happening here? We have alkene. Hydrogen halide means hydrogen is present. Halogen is also present. That is HX. That is our hydrogen halide in CCl4. So what is forming here? To one carbon, a halogen is going. To another carbon, one hydrogen is going. So what we are getting? Alkyl halide. So alkene to alkyl halide. That is addition of hydrogen halides here, right? So what about the mechanism? There is a double bond. So there is a double bond present. HX is coming. If HX, that is H plus, there is a delta plus. X is more electronegative. So delta minus is there. Then there will be shift of pi electrons in the presence of HX. Then what will happen? There will be breaking of the bond, HX bond. Then what are the products obtained? H plus and X minus will be formed. Okay, so here is a double bond. Pi electrons are getting shifted. Suppose pi electrons are shifted to this carbon, it will get negative charge. This will get positive charge, right? So here we have H plus and X minus. So first H plus, that is our electrophile E plus. That is going to the alkene. So H plus will go to this carbon and get attached. So what is formed? Carbon, there is one hydrogen. What about the next carbon? It has a positive charge. So first step is electrophile is getting added. So I can call it as electrophilic addition reaction. Electrophilic addition reaction. Okay. What about the next step? X minus is waiting here. So carbocation is formed. C plus, X minus, negative charge. So X minus will go to this carbocation. So that halogen is added to next carbon. So this is a product obtained here. So carbocation is formed. If carbocation is formed, then rearrangement. You have to check the rearrangement. So last case we have studied 1,2 hydride shift. Whether it is possible or not, you have to check it. So this is happening in the addition of hydrogen halide. So let us check the examples. We have ethene, CH2 double bond CH2. Then we have hydrogen halide. I have HBr. There is H plus, there is Br minus in the presence of Cl4. Then break this. What to do? Break the pi bond, add hydrogen to this one, bromine to this one. Or you can add bromine to this side, hydrogen to this carbon. You will get the same product. So this is bromoethane. Otherwise, you will get CH3, CH2, Br. This is also bromoethane. So wherever you want, you can add H plus and Br minus. So that is the point. Then we have butadiene. So they are symmetrical alkene. First, we are studying about addition of hydrogen halide in symmetrical alkenes. So there is a double bond. Then I have to add halogen. I have to add hydrogen. So what is happening? What is happening? You have to add hydrogen, then Br, or you can add Br to this carbon, hydrogen to this carbon. Fine. You will get the same product. So here you are getting CH3, CHBr, CH2, CH3. That is our 2-bromobutane. Then the second one, second type of addition also, you will get the same product. In that case, you will get bromine this position. That is also known as 2-bromobutane. Okay, so symmetrical alkene. How we can add this hydrogen halide to symmetrical alkene? That is clear. So wherever you want, you can add it. So you have to break the double bond to this carbon. One carbon, give some hydrogen. Then to other carbon, give a bromine. So that is a point here. So racemic mixture. Why? This carbon. 4 different groups are attached to this carbon. So racemic mixture. So what about addition of hydrogen halides in unsymmetrical alkenes? So unsymmetrical, I have an unsymmetrical alkene, right? So R, CH double bond, CH2, HBr. Okay. Then what will happen here? There are possibility of 2 products. One is 2-bromoalkane. Other one is 1-bromoalkane. So which one will be the more stable? Which one will be the major product? How can we decide? There is a rule for that. For unsymmetrical alkene, which is a major product, so it is based on Markovnikov rule. So what is Markovnikov rule? We will study about that. So I'm taking unsymmetrical alkene. I have H plus and Br minus. In this reaction, carbocation is intermediate. If carbocation is intermediate, you have to check possibility of rearrangement. So let us check that one. So CH3, CH double bond, CH2. Okay. Then here, this carbon is taking one hydrogen, right? So positive charge will be formed on this carbon. So what about this carbocation? Primary, secondary, or tertiary? So this carbon is attached to 2 more carbon atoms. So I can say it is a secondary carbocation, right? So what about the next one? Here, if this carbon is taking one hydrogen, positive charge will be formed on the terminal carbon, that is CH2 plus. This is attached to one carbon atom. So I can call it as primary carbocation. Which one is more stable? Secondary carbocation or primary carbocation? Of course, we have studied GOC. Secondary carbocation, the intermediate, that is more stable. Then we can write the product also. Next, Br minus is coming. It is getting attached to carbon with positive charge. So I will get 2 products, right? So here it is a 2-bromo. Second position, there is a bromine, 2-bromopropane. Here, what is that? 1, 2, 3, 1-bromopropane. So which is a major product? So this is a major product. It is based on what? Based on the stability of carbocation. We are deciding this one. Okay. So that is about unsymmetrical alkene. You have to check the stability of the intermediate form. So carbocation, which carbocation is more stable, then that product will be the major product. So that is it, addition. So what is Markovnikov rule? That is hydrogen or electrophilic part, H plus of the attacking molecule gets attached to that carbon, which have more number of hydrogen atom. Confusion, right? So let us check it out. So CH3, CH double bond, CH2. So this is first carbon, this is second carbon, right? So we have to add hydrogen. First step, addition of hydrogen. So which carbon we have to add that? So check the number of hydrogen atom attached to this carbon. That is only one hydrogen. What about this carbon? There are 2 hydrogen. So Markovnikov rule says that carbon with more number of hydrogen atom, right? So that is this one. To this one, our hydrogen will be going, or the positive part of addendum will be going to carbon atom, which have more number of hydrogen atom. So that is a major product. So HBr, then 2-bromopropane, that is a major product. To this terminal carbon, one hydrogen is coming. To this one, carbocation is formed. Then Br will be attached to this one. So 2-bromopropane is a major product according to our Markovnikov rule. That is it. Markovnikov rule. So what do you have to study? So positive part or H or E plus will be attached to that carbon atom, which contains more number of hydrogen atom. So what is the reason behind that? We have checked the stability of carbocation, right? So based on the stability of carbocation, Markovnikov proposed rule, that is known as Markovnikov rule, right? So that is it. What about anti-Markovnikov addition? Anti-Markov means it is opposite to Markov, right? So what is anti-Markov? We have HBr. HBr, the presence of a peroxide. So what will be happening? What will be happening opposite to that one? So Markov says that this hydrogen will go to carbon with more number of hydrogen atom. Here it is opposite. So check it. Here one hydrogen, here two hydrogen. So our new hydrogen should be coming to this carbon. Is it correct? No. Actually, to this carbon, a new hydrogen is coming. It is opposite to Markov's rule. That is why it is known as anti-Markovnikov addition. So Cr, CH2, CH2Br. There is no carbocation form. Here actually, intermediate formed is a free radical, free radical. So you know how to find the product, Markovnikov's product. Then HBr in the present, only for HBr. HI, no anti-Markov. HCl, no anti-Markov. Only for HBr in the presence of peroxide, we have to follow anti-Markovnikov's addition. That is 1-bromo alkane is a major product. Last case, 2-bromo. Okay, here it is 1-bromo. So that is all about anti-Markovnikov's addition. So it follows free radical addition. Free radical. So free radical mechanism, it is following. So I have two homework questions for you. These are the homework question. So we know HBr. So H plus, H plus, H plus, addition of H plus. So this reaction is known as what? Substitution, addition, etc. So take it as a homework question. This one, take it as a homework question. CH2, CH, CH3 plus HBr. H plus, first step, H plus. So H plus means what? Electrophile or nucleophile or free radical. So what is the name of this reaction? Okay, so that is one homework question. Then second one. So I have an alkene, the reaction of alkene in the presence of HBr. Here there is no peroxide. In the presence of peroxide, anti-Markov. Here it is Markovnikov's rule, Markovnikov's rule, Markovnikov. Okay, not anti. In the presence of peroxide only, anti-Markov. So here you have to do the product. Then I will give you a hint. There is a chance for hydride shift. We have discussed hydride shift, 1,2 hydride shift. Why? To attain more stable carbocation. So you have to write the mechanism and find the product. So in between, there will be an intermediate. So you have to check the stability. If some rearrangement is possible, you have to do that. Why? To get the more stable carbocation. So that is a homework question for you, right? So based on Markovnikov's rule, you have to do this one. Okay, it's almost time is over. We will stop it here. Okay, then JNV, Hailakandi. Okay, bye then. Bye bye. See you. See you in the next class. That's all about today's class. We have studied so many reactions, so many mechanisms. So try to revise the things and we'll do more problems in the next class. Okay, then bye bye, students. We will see you in the next class. I'm ending the meeting here.